then divide by the 182.701. So we type in essentially 750 divided by 182.701. Since this is 3 sig figs, we want to keep 3 sig figs, and that comes out to 4.11. Our grams are gone, so we're left in moles of that stuff, and we want to write the full unit there. So for this one, we'll do 750 divided by 39.997. That comes out to 18.8 moles of NaOH. Now, if this part is slightly confusing, there is another video under the Unit 5 playlist entitled Finding Molar Mass. Check it out. If going from grams to moles kind of gives you some issues, there's a video specifically titled Mole Math, Grams to Moles. Check it out. Now, Part C asks us to determine the limiting reactant and asks us to show our work and then fill in all parts of the BCA. Now, if you are not in Able Chemistry, BCA is a table where we chart the before amounts in moles, the change amount in moles, and the after amount in moles. Essentially, we're doing lots and lots of math and just organizing it in an easy-to-read table. But it can be done with your traditional dimensional analysis options. Now, we already have a balanced equation, so we're going to drop our coefficients. But remember, when it says limiting reactant, we have to do our limiting test to determine what is the limiting reactant. So, before we do anything, we want to drop what we know. We know that we are starting with 4.11 moles of the nickel 2 nitrate. We're starting with 18.8 moles of sodium hydroxide. And we know these two numbers because they were our answers from Part B. Now, we also know that we never have products before the reaction actually happens. So when we do our limiting test, since by definition the limiting reactant limits how much product is made, the easiest way is to take your mole amounts for each reactant and test and see how many moles of product it will make. It doesn't matter which product you use. I personally prefer to just always use the product right after the arrow because it makes me happy. So I'm testing to see how much each reactant will make of this product. So I'm going to kind of label it. So if I'm starting with my nickel NO3, well, I start with its mole amount, 4.11. Now, when we're using our BCA table, we multiply by where we're going. So we multiply by the coefficient next to the product we're looking at. We divide by where we came from. So if I'm writing that out, I'll do 4.11 times 1, this one, divide by where it came from, so that I know that if this is my limiting, I'm only going to make 4.11 moles of the product. So if I test the other reactant, which was their NaOH, I'm starting with 18.8 here. So if I multiply by where I'm going, and I divide by where I came from, I'll be multiplying by 1 and dividing by 2. Then that comes out to roughly 9.4 moles. Now remember, our limiting limits. So because 4.11 is less than 9.4, our NiNO3 2 is my limiting. So if this one's my limiting, then this is my excess, meaning I'll have this left over. So in my class, we represent our limiting with a star. Now, it's not always the far left. It just so happens to be there. But when we know it's limiting, limiting means it gets used up. So in our BCA table, to show that it was used up, we'll subtract it so that we have 0 of that reactant in the after. Now, to find out the change row, we use our process of multiplying by what you want and divide by where you came from. And our where it came from will always be the coefficient above the starred limiting reactant. So if I start here and do 4.11 times 2, and then divide by 1, that comes out to 8.22. And we're going to represent that this amount of reactant was used by putting a negative. So to get this number, we start again, 4.11 times 1, divide by 1, and that comes out to 4.11. Since this is product, it's being produced, so I'm going to represent that with a plus sign. And then to get to this number, I start at my star again, 4.11 times 2, divide by 1, And that comes out to 8.22. And it was also produced. And then to get your after row, you're going to do either your subtraction or addition, depending on which side of the arrow you're on. So when you do 18.8 18.8 minus 8.22 comes out to roughly 10.58. Now this would be your amount of the mole amount of sodium hydroxide left over. Our nickel 2 hydroxide had 0 plus 4.11, so we're going to produce and have 4.11 moles of nickel 2 hydroxide after the reaction is done, and we'll have 8.22 moles of sodium nitrate after the reaction is done. Now, if we continue to where if the question asks us what is the limiting reactant, well, I marked that in my BCA table. So the limiting reactant in this problem was the nickel 2 nitrate. Okay, so that means the excess reactant was our sodium hydroxide because it was left over. Now we're asked how many grams of sodium nitrate should be produced. Well, it's asking us for grams of sodium nitrate, but it doesn't give us a starting number. So that means we need to refer to our BCA table to get our mole amount of sodium nitrate that we're starting with. Since sodium nitrate is a product, we know that we made 8.22 moles, so our starting value will be 8.22 moles of sodium nitrate. Once I know that it's moles, they've asked me for grams, so I know from my mole chart that for every 1 mole, there's a specific number of grams, and I can find that specific number of grams by calculating the molar mass. So for this particular compound, we have 1 sodium plus 1 nitrogen plus 3 oxygens. So the molar mass of sodium, as we've seen previously, was 22.990 on the periodic table, plus the molar mass of 1 nitrogen, which is 14.007, plus the total molar mass of 3 times the molar mass of oxygen of 15.999. When you put all that into your calculator, it comes out to 84.994 grams for that 1 mole. Once we know this value, since both our numbers are on top, remember this is essentially a large fraction, 8.22 times 84.994 comes out in the calculator to roughly 698.65. Well, since our starting number had 3 sig figs, that means we need a round of 3 sig figs. We start from the left, 1, 2, 3. We look to the right, 6 is larger than 5, causing the 8 to round up. So our final answer will be 699 grams sodium nitrate. We know it is grams because our moles divided out, and life is good. Now remember, for vocabulary, since this is the amount of product, this is our theoretical yield, the maximum amount of sodium nitrate this particular reaction can produce. So if an experiment produced only 355 grams of sodium nitrate, and they ask you what is the percent yield, you have to remember that percent yield is defined as your actual yield, which in this case was given in part G, divided by your theoretical yield, which you found in part F. And since it is percent, you'll be multiplying that by 100. So your actual percent yield for this problem will be 355 divided by 699 times 100. That comes out to 51%.